Machine learning elements of reinforcement learning. It is said that reinforcement learning, RL, is a type of machine learning that involves an agent learning how to take actions in an environment to maximize a cumulative reward signal. And on that basis, there are four key elements of a reinforcement learning system: environment, agent, reward signal, and learning algorithm. In their book, Reinforcement Learning, An Introduction, 2nd edition, Richard S. Sutton and Andrew G. Barto makes an interesting argument where they mentioned that beyond the agent and the environment, one can identify four main subelements of a reinforcement learning system: a policy, a reward signal, a value function, and, optionally, a model of the environment. Let's see one by one. Policy. A policy defines the learning agent's way of behaving at a given time. In reinforcement learning, RL, a policy is a set of rules that determines the actions that an agent should take in a given state. The policy maps the current state of the environment to a probability distribution over actions. The goal of the RL agent is to learn the optimal policy that maximizes the expected cumulative reward over time. It corresponds to what in psychology would be called a set of stimulus-response rules or associations. In some cases, the policy may be a simple function or lookup table, whereas in others it may involve extensive computation such as a search process. There are two types of policies in RL. Deterministic policy. A deterministic policy is a policy that maps each state to a specific action. For example, a deterministic policy might always select the action with the highest expected reward for a given state. Stochastic policy. A stochastic policy is a policy that maps each state to a probability distribution over actions. For example, a stochastic policy might select actions randomly based on their probabilities. The choice of policy depends on the nature of the problem and the available information about the environment. In some cases, a deterministic policy may be more appropriate, while in others, a stochastic policy may be necessary to explore the environment effectively. In a nutshell, the policy is the core of a reinforcement learning agent in the sense that it alone is sufficient to determine behavior. Next is reward signal. A reward signal defines the goal of a reinforcement learning problem. On each time step, the environment sends to the reinforcement learning agent a single number called the reward. The agent's sole objective is to maximize the total reward it receives over the long run. The reward signal thus defines what are the good and bad events for the agent. The reward signal is a scalar value that can be positive, negative, or zero. It represents the immediate feedback that the agent receives from the environment after taking an action. The reward signal can be a function of various factors, such as the current state of the environment, the action taken by the agent, and the goals of the RL system. The reward signal is a crucial component of the RL system since it guides the agent's behavior towards achieving the desired outcome. The agent learns to associate certain actions with positive or negative rewards, and it adjusts its policy accordingly. The agent's goal is to maximize the cumulative reward over time, which requires a balance between exploring new actions and exploiting previously learned information. In RL, the design of the reward signal is an essential part of the problem since it determines the behavior of the agent. A well-designed reward signal can help the agent to learn quickly and efficiently, while a poorly designed reward signal can lead to suboptimal behavior or even failure of the RL system. In general, reward signals may be stochastic functions of the state of the environment and the actions taken.